2.2, linear functions. First, it's important to know what a linear function means. Here's a hint. So when you're looking at a graph, you're looking to see whether or not it's a straight line. The graph on the left is a straight line, so that means it's a linear function. The graph on the right is not, so it is not a linear function. One thing you'll need to do in Algebra 2 is figure out whether or not, by looking at an equation, is this equation linear? Does it represent a linear function? So we're just going to go through a few examples here. If you take a look at example 1, y equals x plus 5, I really hope you are familiar with this form of linear equation back from Algebra 1, geometry, possibly even in middle school. And this is in the form of y equals mx plus b. And so yes, this is definitely a linear equation. Take note that the y doesn't have any exponents attached to it. Same thing with the x, no exponents attached to it. Number 2, really hoping you're also familiar with this type of equation by looking at the, just looking at the form of it. As you can see right here, I have a squared term, a squared x. That implies that this particular equation would be a parabola. The graph of this equation would be a parabola. And if you didn't recognize that, don't worry, because we're going to be certainly practicing with the different types of equations. But a parabola looks like this. It's that U-shaped graph, and it either opens up, it could open down. If the y is the one that's squared instead of the x, it would open to the right or to the left. So the question is, though, is this linear? And no, it's certainly not linear. Take a look at example 3. We could go ahead and solve for y, but I'm not going to do that. I'm just going to try to recognize, just by looking at the equation, whether or not it's linear. Now we can look at the y. There's no exponent attached to it. Same thing with the x. There's no exponent attached to it. It's not underneath a radical or anything like that. On the next slide, I'm going to tell you exactly what things to kind of look for. But for right now, this would be a linear function because, like I said, it doesn't have any exponents, and you'll see in the next slide the different things we're going to look for. Example 4, we can see this radical right here, and because there's that radical right here, this is not a function, and if you have your graphing calculator with you, I would recommend solving this equation for y. So we would just subtract the square root of 3x from both sides. And take a look at the graph. Put it into y equals and look at the graph of this function. And that's another way you can certainly tell whether or not an equation is linear, by solving for y and graphing it. In example 5, we see that there's a number being divided by x, and that is also not a linear function. And same thing I would recommend is graph this. Take a look at what the graph looks like, and you'll see that it definitely is not linear. You try example 6. So here's what to look for. First, here's a tip. Hopefully you remember this back again in Algebra 1, or maybe it was covered in geometry. F of x really just stands for y. So if you have a function, say f of x equals x plus 2, that would be the same thing as y equals x plus 2. And so I'm going to go through and tell you what to look for when you're looking at equations. This is really important to remember, and it's pretty straightforward. We're going to start with linear. So it's going to be a linear equation if there's only an x and only a y. It's not linear if this is the case. X or y have a power other than 1. So again, if it's x, remember if there's no exponent, it's assumed to be 1. So if you see x squared or x cubed or x to the 1/2, something like that, something other than 1, kind of want to change this to say a power other than 1 instead of greater than 1, then it's not linear. Here's another way it's linear. X and Y are both to the first power and there's no roots. Okay, so it's kind of going along with the first two things here. Another way you can look at it is X is by itself and Y is by itself, and it's not being multiplied by each other, and that's coming up in the next few clicks here. It's not linear if there's a square root, not linear if the variables are being multiplied, and not linear if the number is divided by a variable, as we saw in one of the examples. So now we come to X and Y intercepts, and this is just one way to sort of graph a function and see if it's linear. This is just one other way to look at it instead of looking for the different things in the equation. So if I'm looking at this equation right here and I want to figure out the X and Y intercepts, try to make sense of this, and I know that all along the x-axis, the y value is 0. And all along the y-axis, the x value is 0. So to graph the x and y intercepts, remember what that means first. The x-intercept is where the graph crosses the x-axis. The y-intercept is where the graph crosses the y-axis. And so if I want to find the x-intercept, I know that my y value has to be 0. So what I would say is you can go ahead and substitute 0 in for y and bring the rest of this down. Another way to kind of look at it though, because 0 times anything is 0. So another way to look at it is just to kind of cover up the y term and solve it from there. Of course, don't lose the other side of your equation, that we would have a 0 right here. And so I would have 0 is equal to negative 4x plus 6. And then I'm just going to solve for x. So I'm going to go ahead and add 4x to both sides. Divide by 4. And you can certainly reduce. Your calculator can also reduce for you, but I hope that most of you can reduce that. So I have x equals 3 halves. And I'm going to go ahead and plot that on the x-axis. So remember, 3 halves is really just 1.5. So I'm going to go ahead and plot that point. And that's the x-intercept. For the y-intercept, as I said a little while ago, the x value is 0. So now, instead of blocking off the y term, I'm going to block off the x term and just rewrite this. So again, just to remind you, I would be substituting in 0 for x. But because I would do that, negative 4 times x would be 0. So I'm just going to block that term. And so I have 2y is equal to 6. Y equals 3. So I'm going to plot that on the y-axis. And then I'm just going to connect it with a line. Okay, remember this graph keeps going, so we're going to go ahead and put arrows on the end of the line. And we can see that this certainly is linear. So I'm going to give you one more example to try by yourself. And I'd like you to go through the same thing, find the x-intercept, find the y-intercept, and graph it. And you can just draw a quick sketch of your graph in your notes. All right, and we'll go over more of this tomorrow.